The command line is a powerful tool for us developers, but it's not the most user-friendly way to interact with a computer. It can be hard to remember steps in a multi-step process, hard to remember all the command line switches we need to have for our commands to run successfully, and hard on our bodies to type out all those commands over and over again. Thankfully, Make can make our lives easier. In this video, we'll discuss what Make is, how to create a Make file, and how to speed up your development workflow using Make. Hello developers, and welcome to the PHP Architect channel. If this is your first time here, my name is Scott Keck-Warren, and on this channel we discuss a wide variety of topics related to the PHP ecosystem. Make sure you subscribe and hit that bell so you're notified when new videos come out. The Make command line tool is used to determine what portions of programs need to be recompiled, so developers don't need to recompile the whole source tree for every little change that they make. Make is generally used for any development environment where you have a complex build, test, and installation process. If you're an experienced enough Linux user, you may remember installing software from source using Make for every package that wasn't part of the main distribution. The Make command line tool consumes Make files, which are used to create links between target files and their inputs, which the Make command line tool uses to determine if and what files need to be rebuilt. For our examples today, you'll need to have a terminal and Make installed, but the chances are that if you have some sort of Unix environment, you probably already have it installed, as it's a required tool for most development environments. So you may be saying, well, that's great, Scott, but I don't need to install software, so why should I care about Make? As a PHP developer, I use Make for three things regularly. The first being multi-step processes my team runs regularly, like a build process. It also is helpful for keeping track of complex commands that we run occasionally, such as running the code coverage report out of PHPUnit, which can involve a lot of command line switches. And then any command that we run a lot, like our pre-commit scripts. Make is also built to keep track of how input files are related to output files, so it's possible to structure your Make file to reduce the total amount of time you spend running commands. We'll talk more about how to do this and more after this word from our sponsors. Do you want higher clarity in production but don't have the time to earn your degree in observability? Me too. Forget logs, metrics, and traces. Honeybadger Insights is built around structured events. When you send your application logs and other events to Honeybadger, you'll unlock the power of Honeybadger's powerful new querying language, BadgerQL. You can then use BadgerQL to ask any question about your data, convert any event into a metric, and chart your metrics on a custom dashboard. You can do all of this on Honeybadger's free plan as part of their comprehensive monitoring suite, which includes error tracking, uptime monitoring, status pages, and more. Speaking of error tracking, did you know that an error is really just a first-class event in Honeybadger? In fact, you can use Insights and BadgerQL to explore all of your existing Honeybadger data in new ways. It's pretty cool. Give it a try today at honeybadger.io. That's honeybadger.io. Make stores its configuration inside of specially formatted text files called makefiles. By default, the make command is going to look for a file named makefile in the current directory, but we can change this to fit our team's needs. On our team, we have a makefile at the root of our project that consists of the things that can and should be used by everyone on our team. This file is included in our source control, so we can keep it up to date across the team, and can even have it dependent on the branch we're working in, which can be helpful when we're doing upgrades. We also allow a makefile.local that's ignored by source control that can contain commands specific developers find useful in their local development environments. Let's create a basic makefile that just echoes out hello developers. We can then run make with no target, and it will run the echo with our message as it's the first entry in the makefile. Let's talk about how that worked exactly. So a makefile consists of a series of rules with rules that look generally something like this, where the targets are generally the name of the file that this rule will create or modify, commands that are a series of steps used to make the target. It's important that these start with a tab character and not spaces, or we'll get syntax errors. Prerequisites are a list of space-delimited targets. These can also be called dependencies. These prerequisites need to be satisfied before the commands for the target are run. An interesting part about this target dependency setup is that the prerequisites don't actually need to be files. They can be aliases to another command we want to run before this command runs. For example, at least once a month, we need to run an update on both our composer lock and our package.lock, which you're doing, right? We have packages that also require us to publish the newest version of their assets, which in this case is Horizon. So our goal is to make this as easy as possible for our developers. But occasionally, we also need to update one or the other, so we have the following update section in our makefile. We can update just composer.lock or just package.lock using make update composer and make update npm, or we can update both using make update all, because we have the update composer and update npm as prerequisites. Then when somebody eventually creates another package management system, we can easily add it to the update all target by adding it as a new prerequisite. Once we've updated our lock files, we then need to distribute those changes to our team so they have the versions of the packages that we're using everywhere else. Obviously, we don't want to install our packages when there are any changes, as there is a non-zero amount of processing involved in this. To prevent this, we're going to use a feature that Make brings to the table, which is that it will check the modified dates of the target and the prerequisites. And if the target's modified date is after the oldest modified date of the prerequisites, it won't run the commands again. We'll create a target called composer.json that has a prerequisite of composer.lock. In the composer.json command, we'll run composer install and then touch composer.json, which will then set the modified date of the composer.json file. We'll also create a target called composer.lock because it's a prerequisite of composer.json, but there's nothing to do as nothing needs to be updated at this point. So the first time we run make composer.json, it will run the install process and touch the composer.json file. Then if we run it again, we'll get the message that composer.json is already up to date, and it won't run the install. This is what makes make ideal for developers of compile languages, but that doesn't mean we can't use it as well. The last feature of make that we're going to discuss is using variables. I'm a fan of using heavy amounts of static code analysis on my code to find potential bugs before it reaches production. And we can do this with make using the following setup. Now, one of the things I hate about this process is that it takes too long to run all the static code analysis tools against all of the files in my project. And the feedback loop of pushing the files to our testing infrastructure is just too slow. That's why I like to run static code analysis tools on just the files that have changed. Using variables in make, we can make this process a little bit easier. First, we're going to define a variable called changed.php files that defines a run of PHP diff to find the staged files that have been added or modified. We're not actually running the command here, we're just creating a variable to keep that command easy to reuse. Then we can call that command and pipe it through xargs, so we can run phpcs and phpstand with just those files. Then when we realize we need to add the database directory as well, we can easily change it in just one spot, and it'll update on all the existing commands. I also like to tie this into Git's pre-commit script process, so we can run these tools automatically whenever we make a commit. Make is a super powerful tool, and we're barely scratching the surface of it at this point. Chances are, if you're attempting to automate your build process, there's a way that Make can make it easier for you. I would love to hear from you in the comments about how your team is using Make for your PHP development, especially if it's not included in these things that we've already discussed. As a recap, Make is a command line tool generally used to build compiled programs. We can use it to make repeated tasks easier. Targets provide commands we can run, and we can use the modified date to prevent reruns of the same target. I hope you enjoyed our video. If so, make sure you subscribe, comment, share, and like, as it does help others find us. Are there topics you'd like to see us cover, or have there been some things that you've learned about Make in this video that you can now bring to yourself? Let us know in the comments section below. I would love to hear how I've helped you. This is Scott Keck-Warren for the PHP Architect channel signing off, and reminding you to keep watching, keep coding, and keep reading.